All right, we're picking up here with number 16. We're still sketching the line of each graph. And so I left this up in the top right-hand corner. That's still our goal. We need to end up in this slope-intercept form. So we start out with this equation. X plus 5y equals 20. We want to get y by itself. Okay, so first order of business, we subtract x from each side. Notice I didn't write these two over top of each other. They're not like terms, so we cannot combine them. So I have 5y equals. Once again, we can't combine them, so they're just going to sit there next to each other. And if they're going to sit there next to each other, I might as well write the x term first because that's what it needs to look like in my goal. So this is a negative x plus 20. This negative sign attaches to the x, and the positive sign that's understood to be here attaches to the 20. Final order of business, I've got to get y by itself, and this is multiplication in between them. So to undo multiplication, I divide by 5, and I divide every single piece by that 5. What I get is y equals. Now, here's a part that trips people up, and you need to start getting used to seeing this. This is a negative x over a 5, and people look and say, well, I got to just leave it like that because there's no number. Well, if there is just a negative sign in front of x, it's understood to be a 1. Just like if I had a regular x up here, it's understood that there's a 1 in front of that. So what this actually is a negative 1/5, and we write the x out to the side because that shows our slope the best. And then we're dividing everything by 5, so we get a plus 4. Okay? Now, we're going through piece by piece, each single graph, and trying to figure out which one matches that. All right? Again, just like the last problem, the easy part, or the easy place for me to start with on these is with this y-intercept. So anything that doesn't have a y-intercept of positive 4, I'm getting rid of. 2, 4, this one checks out. That's a y-intercept of 4. This one is negative 4. That's not what we want. So B's out of the question. This one, we can't even see it, which sometimes is an issue. But look, we can see our regular 4 here. This is where it should cross, and it doesn't. So that one's out of the question. Our very last one, of course, also crosses at 4. They had to make you at least consider and do a little bit more work. So there we go. Now we have to take into account that final piece of the puzzle, and that is the negative 1/5. I immediately look at that, notice negative slope, that means a decreasing line. Right then and there, I know I'm looking at D. Okay? If you don't, then you have to do some counting, and it's actually kind of tricky to do some counting on this one. So my slope is negative 1/5. This negative sign can either go up here with the rise or down here with the run. Let's put it up here with the rise. You can put it with either one. So if I put it up there with the rise, it's negative 1/5. So I'm going to rise negative 1. That means I've got to go down 1. Well, down 1 is halfway in between right here, and then over 5. 1, 2, 3, 4, 5. So it's right where it should be. D checks out, and that's our answer. To me, it's easier just to notice that, look, that's a negative slope, which means we've got to have a negative, a decreasing line in our answer. Number 17, quick problem. Is the following a function? Okay, you don't need to graph all these. You don't need to do anything out of the ordinary or crazy. Just if we're talking about is it a function, we want to know something about these x values. Specifically, when we're looking at these, we want to say, are they all unique? If they are unique, we have a function. If some of them repeat, we have no function or not a function. So I'm just looking at those x values. That's what we do every time with these type of problems. I see I've got a 1, a 0, a 7. We're good so far. Negative 2, and then a 1. Uh-oh. Check that out. We got a 1 and a 1. So these two, if we graph them on a plane, are going to line up on a vertical line with each other, which would fail the vertical line test. If you ever have these x's that repeat, our set of points is not a function. Okay? Not a function. Fails the vertical line test. Number 18, we've talked about a little bit on our previous attempt at these. It's a vocab problem, guys. We see this word range, okay? Range. I know that range also means y value. It means output, and I see this word domain. Domain means X value or input. Now, one other key piece of information that we learned about these Y values and outputs was whenever we were learning about function notation. And function notation just means this weird f of x sort of thing. And we learned that all that f of x is it's a y. That's just a fancy way to rename it so that we can say it's a function of x. It's just a y. We learned that you can interchange those. So it says, what is the range? We want to know the range, so we want to know this y. If the domain is -2. So they told us what the x value is of -2. So when I've got my function f of x equals 5, and they told me what x was, -2 minus 3. When I solve that, I get -10 minus 3, which is -13, and that's my answer. All right? 19 is very similar, except for this time they gave me the range. Range is 5. Well, range means y value, or it means f of x in this case. So I take this range, this f of x, and that's what plugs in for my left side. So what I have is 5 equals -x plus 7. Now I'm just solving the equation. Subtract 7, subtract 7. I get -2 equals -x, and I divide by -1. Remember, that's a little math trick, and I skip over that quickly in this problem. I skim over it, but that's a pretty important math trick. If we want that x to be by itself, that negative sign's a problem. So to do that, we divide everything by -1, and it switches everything's signs. X equals 2. Okay? Number 20. Number 20 gives people fits, and it doesn't need to. Look, we actually know what this equation is. We have this written in our notes. This is the standard form equation. And it says solve it for x. Well, guys, we've been solving these equations for x all year long. We've done it a ton of times. Just because there's no numbers here doesn't mean it works any differently. We want to get x by itself. That's what solving is, getting it by itself. So let's pretend, look, if this didn't say by, let's say it said 3y. 3y instead. And I said, I want x by itself. You tell me, well, that's easy, Mr. Sorrell. We got to subtract 3y from both sides. I got to get that whole piece moved over. Well, this problem doesn't say 3y. It says by, but it works just the same. So we subtract by from both sides. If there were numbers, you'd be able to do it. Don't let the fact that there are no numbers confuse you. Okay? So on the left side, I've got ax equals c minus by. They're not like terms. I can't combine them. For example, again, a lot of people look at this and they say, oh, well, I guess I'm done. I can't really do anything else. X is as good as it's going to get. What if this wasn't an A? What if this was an 8x? Will you tell me? This is easy, Mr. Sorrell. This is a simple problem. I just got to divide each side by 8. Divide each side, divide every piece by 8. Okay? And I'd say, yeah, you're right. That's great. Don't let it be any more confusing because it's letters. Just because it's letters doesn't mean it doesn't work. Divide by A. Now, you'll notice I did not write A under every single piece. That's optional. Just know that this is the same exact thing. Whenever I say divide each piece by A or divide each piece by 3, I write it under every piece because that helps people out visually. But if we write an A under here, it says I've got to divide this whole piece or both of these pieces by A. It just looks prettier to leave it this way whenever we're talking about these equations that have no numbers in them, these literal equations. So an acceptable answer would be to leave it just like this. The alternative answer, the one we learned on Wednesday, and they usually only do this when the bottom item, the denominator, is an actual number. They may write it like this. Personally, I do not like that second answer. I don't like it. I like the first answer. It's cleaner. It's easier to see what's going on. I like it better. Okay? But just know that if they give you this on the test, this is also an acceptable answer. It's perfectly fine. Either of them work. Both of them are correct. Okay?